All right, we are ready for example 2. Example 2 is a little different because you'll notice you have a lot of words and just one graph. Before we had a graph and a table, so it kind of looks to me like we're going to have to take these words and make our own equation to go onto this graph. Let's give it a read. Your employer has offered to pay 2 pay scales for you to choose from. The first option is to receive a base salary of $250 a week plus 15% of the price of any merchandise you sell. The second option is represented in the graph below. Compare the properties of the functions. Now remember from example 1, when I said compare, I wanted you to mention the average rate of change. And I wanted one other thing. The other thing I wanted was the y-intercept. So it looks to me like I could find the average rate of change in the y-intercept for the function down here. So the only other thing I need is my first option. And it says I can receive $250 a week plus 15% of the price of any merchandise you sell. So looking at that, I want you to decide if you think it's going to be linear or exponential. And then let's go on ahead and write an equation for it. All equations start with y equals. If you went linear, you done did good, kid. Oh, just kidding. If you went exponential, that's where you done did good. The 15% is what kind of gives it away as exponential. So I want to use the form a times b to the power of x, but I want to plug in this particular information. So I'm going to go with y equals, a was my initial amount, that's the $250 a week. And now b is my rate. So I have 15%, and you want to think to yourself, is it going to be 100 plus 15 or 100 minus? And it is going to be 100 plus 15. So we get 150 or 1.15 all to the power of x. This equation came from the information up here. What I want to do now is I want to graph this equation maybe a little bit. And the best way to do that is probably just to go on ahead and put it in your calculator. You want to turn your calculator on, and you want to go to y equals, and you plug in 250 parentheses 1.15 all to the power of x. Kind of just how your formula was. And then let's go on ahead and look at our table. So starting right away, I can see that my y-intercept is 0 to 50. 0 to 50. And let's graph a few more points. 1 should be 287.5. Oh, that goes in hundreds. Alrighty then. Then we'd have to scroll all the way down to 100, and that would be a lot of scrolling. So maybe we won't actually graph it on here. Maybe we'll just look at our table, kind of like we did with example 2. So I'm going to go on ahead and copy down a few points from my table. I'll go 0 to 50, and I'll go with 12875. I kind of wonder if there's like another perfect number. There is 7665. And the reason I skipped all the way down to 7 is because I know I'm going to do my average rate of change formula, and I feel like those two would be the easier to put in the formula. Alright, so we need to call these something so we can tell a difference between them. Let's go on ahead and call this guy f of x, and then let's call this function right here g of x. And you don't have to use the same letters as long as it's really clear. It's going to make our comparison easier. So I want to find the average rate of change for f of x. Average rate of change. And again, that's where I use my formula, y2 minus y1 all over x2 minus x1. So I have to read specific points on my table to get my x and my y. If I look at this at 0, it's at 200. And let's see if we can get another point. I feel like right here's another really good point. So that's over 500 up to 300. 500, 300. Alright, so we're going to go on ahead and we're going to plug it into the formula. y2 is my second y value, 300, minus y1 is my first y value, 200, all over x2 minus x1. 300 minus 200 is 100. 500 minus 0 is 500. This simplifies down to 1/5. So it is growing, it's just kind of growing at a smaller rate. And now I want to do the same kind of thing, but this time for my table. So g of x, average rate of change. If you need to pause this video at any time to copy these numbers down, you totally can, but I would like to see all of this math in your notes, please. Alright, so for g of x, let's use the 0 to 50, and let's use the 7665, because those are perfect points. We don't have to have this ugly decimal. Alright, so y2 would be 665 minus 250, all over 7 minus 0. I don't know what 6625 is off of the top of my head, so I'm going to go on ahead and put it in my calculator. 665 minus 250. I get 415 all over 7. And I'm going to go on ahead and see what that divides to, divided by 7. It is a decimal, but I'm going to go with 59.3. Approximately 59.3. Does that look like it's a bigger number than 1/5? It should, because it definitely is. So when I go to compare them, I want to say that g of x has a greater average rate of change. Are they both increasing or both decreasing? Well, if I look at the numbers in my table, they're definitely going up. And if I look at my picture, it's going up. So I want to say they are both increasing. And then the last thing I want to say is the y-intercepts. That's the only point that I plotted, 0, 250, and the other one's 0, 200. So they're pretty close to each other, but I would say not f of x, but the one from the table. G of x has the bigger y-intercept. G of x has a greater y-intercept. And right here, I've officially answered the question. I have my comparison, and then all around it, I have my math.